Hello everyone, many thanks for your interest. For the past 2 nights, July 23rd and 24th of 2018, I've been observing the beautiful waxing gibbous moon. And mare Serenititis is an impressive sight. You know, you can see the difference in contrast, in tonality. The color is lighter compared to adjacent mares, you know, Tranquilititis in the south and mare Imbu in the east. And this difference in color is because the albedo, Serenititis, has two rings. The inner ring is clearer because it has a high albedo or reflectivity, and this is most probably due to the lower concentration of iron and titanium dioxide, whereas the outer ring has a low albedo and high concentrations of titanium dioxide and basaltic material, hence the darker color. The Sea of Serenity has been degraded, not such as extent as the Sea of Tranquility, but it is very, very degraded. And this is as a result of the Preimbrian impact. You know, when an impact crater is formed, the material which is displaced or excavated is deposited. It goes all the way up and is deposited in the continuous ejecta blanket, and it covers the whole crater floor or basin floor. And Serenititis show signs of being affected by these impacts, and also by the Tycho event as well. One area of the Sea of Serenity is the Taurus mountain range and the crater Taurus Littrow, because it has been the subject of investigation by the Apollo missions 15 and 17. And this was as a result of the spectral imaging done by the lunar orbiters. I mean, the last manned mission to the moon was the Apollo 17. Clementine was a mission that we sent back in 1994 to do a global mapping of the moon. And it was an initiative by the Department of Defense, the American Department of Defense, the DoD, in conjunction with NASA, and also in collaboration with several laboratories: the Naval Research Laboratory, Lawrence Livermore, the Jet Propulsion Laboratory, JPL, and the Goddard Space Flight Center. But it had a more kind of defensive objective. The idea was to test some light sensors in space conditions for future applications. Initially, you know, tested on the moon and also in asteroids as well. And the Clementine mission had really high-tech gear. It had really high-spec cameras, you know, high-resolution cameras with a lot of megapixels, you know, ultraviolet cameras, near-infrared cameras, long-wave infrared, and laser imaging system. And you know, they took like, you know, over 2.8 million photos, you know, high-resolution photos of the moon. But we haven't seen many of those. Not many have been released, and there has to be a reason for that. You know. But Clementine had a lot of importance in terms of scientific discoveries as well, because through the investigation done by Clementine, we realized that the South Pole Aitken Basin, one of the largest in the moon, you know, 2,500 kilometers wide and 13 kilometers deep, it had a lot of titanium dioxide, also, you know, water reservoir. So you realize the importance of this vast basin on the moon. I mean, the puzzling thing for me is the fact that Clementine took millions of photos of the moon, high resolution photos, and thus far not many have been publicized, not many have been released to the public, and there were such high resolution photos that they could actually, you know, go close to the surface of the moon and, you know, see any little detail. There must be a reason for that. Thank you.